Hello, everyone. Welcome to the next episode of HPE's Lab podcast from Research to Reality. Today, we have a great honor and pleasure to host Dave Katz. Hello, Dave.
Hi.
Dave is HP Fellow and VP who came to join us with the acquisition from Juniper. You are the first person from Juniper who is on our podcast, so congratulations.
Quite an honor. Thank you.
Would you like to introduce yourself a little bit?
Sure. I'm Dave Katz. I'm a fellow. I'm a coder. I'm a developer at heart. I do architecture because you have to build something. So you architect it and then you build it. I've been sort of self-starting for the last 20 years or so at Juniper. No one actually has told me what to do in a very long time. But I like to do things that apparently are good for the company because they keep letting me do them. My last sizable project was architecting our second system. You know, every networking company has a networking operating system that, you know, is this monster of embedded code. And we needed to build a second one and actually succeeded, which, you know, is a kind of a 50-50 thing in the Valley. But that became kind of my consuming thing for the last decade or so. And I've been seeing it through ever since and strategically firefighting on the sides, trying to position it so that we can actually use it for something going forward more than we've been doing.
So what led you to choose this kind of career? Obviously shaped it the way you like it most.
Yeah, well, I think the career chose me. My sister, who's 5 years older, came home with a textbook for her computer math class in 1970. So I was 12. And this was an electromechanical computer, but it was an honest-to-God computer. You could program by sticking pins into the thing. And she brought me this book and said, I thought you might be interested in this. I picked it up and flipped through it and said, well, yeah, that seems straightforward. And I kind of got excited about it. Then she went off to college and sent back a Fortran book by Decima Anderson, which I thought was a pretty funny name. And I said, oh, this is exciting. I wish I could touch a computer. And then something funny happened about 1970, 71, 72. Certain companies, among them HP, started delivering time-shared basic dial-up services. And so for the first time, a 14-year-old could use as much computer time as he wanted and teach himself the craft. And I got my hands on this thing, dove in. This was an HP 2100 computer with 64K of memory. It was styling. And I was in a public school system big enough to afford one, which was very handy. So I became the kid who they had to throw out of the school at the end of the day when they locked it up. And I just said, well, this is obviously what I'm going to do. I didn't know what that looked like other than I just knew I enjoyed it. HP Basic had the chain statement, which allowed overlay loading, which meant that you could write as much code as you could possibly write and just keep writing it. And that's what I did. Went to Michigan State in 75, went to school for a year, got to the summer looking for a job. There were signs posted in the computer center saying, do you want to work weird hours with weird people? Come to the MSU Systems Group. And I said, oh, that sounds good to me. And I didn't really know what that was, but it turns out this was the group that ran the mainframe with 10,000 users on it that I was using, during the school year. So at the age of 18, I found myself hip deep in systems programming. This was a Seymour Cray invention, so I have a lot of old connections with the company. Mm-hmm. This is a control data mainframe, 12 processors running in parallel, common memory, no interlocking. There's only one interlocking piece of hardware, and the entire thing is a Seymour special. Seymour didn't like locks and interlocks and things. Real men do circular buffers. So that's kind of
locks can be dangerous.
Yes, they can, and it was an amazing pass. I spent 9 years there. I went on to went on to the University of Michigan, where my wife was decided to get a PhD. So after 9 years at Michigan State working on mainframes and front ends and writing X25, for those of us who are old enough, in assembly language and hooking these terminal concentrators to mainframes and all this sort of thing. So that's where, I took to programming like my brain was wired for it. And it's just been, and I'm still doing it after 50 years, and I really enjoy it. So.
And blame it all on your sister.
Yeah, I blame it on my sister, who had no idea what she was unleashing at the time.
So 50 plus years later, you are HP Fellow and VP. What does it mean for you?
Well, it still means nobody telling me what to do, which is nice. I've been given an amazing opportunity that I have, within reason, the resources of what used to be a Fortune 1000 company and is now a Fortune 150 company or something, where they kind of let me do what I want. And what that looks like, I'm getting old, and imagination is the first thing to go. Our imaginations, I think, are based on where we came from, right? And so the idea of, say, running video over the internet just seems absurd, right? There was a point at which that was so remote that it wasn't even worth considering. And what I've learned is that imagination is for young people. My job is to build things. Give me an image of something to build, I can see how to do it. And then I go off and do that.
Now that you mention it, what are these images? What are the products that you built?
Everything that Juniper ever built. I do software infrastructure, operating systems, and so it's at the heart of the entire product line. And none of my kids. I don't. All of my kids are the same. I don't have a favorite, but I enjoy working on infrastructure because it's where the product meets the metal, and it has to be right, and it runs all the time. And I don't know. I've always loved building the guts of it. It's not flashy. You can't point at it and say, "Oh, there's the thing that I built," but it's inside all of them.
So how did you choose your jobs as you were progressing, either within a company or across the companies?
No, it's mostly looking for opportunities, looking for pain points, colliding. I have kind of a odd approach to things. I'm an intuitive person. As when we first met, I sent you an email saying, I'm an engineer, not a scientist. And all of my ideas are intuitive. And I just so a problem will be there. I'll just sort of look at it and say, well, that reminds me of something I've seen before. And a shape starts to form. And sometimes something oddball happens. I say, oh, I'll pull this in. So I end up with strange-looking operating systems that look a lot like routing protocols. Mm-hmm. But they work. And I don't know, I just love, I'm a tinkerer. I'll take words right out of Chandrakant Patel's earlier talk on here. I was born a tinkerer. I've come from a line of tinkerers. My father notoriously got in trouble for taking an alarm clock apart when he was a kid and couldn't put it back together. And he was afraid whenever he came home, he'd find nuts and bolts sitting around the house. I was pre-verbal at the time. He was afraid that he'd slam the door and it would all come crashing down. And so I've always wanted to know how things worked. That's kind of my existential connection to reality is I need to understand how things work.
How did you start interest in data communication?
Accidentally. When I was first at Michigan State, they had these remote batch terminals. Go over to the engineering school. Mm-hmm. There's a card reader and a card punch and all this stuff. And you could see it sort of painting the characters on the line. So it's like, okay, this isn't going very fast. This must be going across a wire. I wonder how this thing works. So I went and dug out the spec for the control data UT200 remote batch protocol and started reading about BiSync and all this crazy stuff and said, this is kind of cool, action at a distance. You can do things from far away with this. This is nuts. Started down that path. And X25 came along. So we had this 35,000 acre campus, and the physical plant decided to put in a broadband cable so that they could control the heating around the campus. And we said, excuse us, can we borrow 6 megahertz off of your broadband cable? And we dropped in these boxes that ran X25, and I said, here, just connect that to there. And I said, sure, give me a mini computer in 6 months and I'll write some code.
And then that campus suddenly became internet.
So how did we get from there? So at Michigan State, the internet wasn't quite happening. So I left Michigan State in 85, which is the internet protocol spec was published in 81, but there wasn't a whole lot of traction. When we moved to Ann Arbor, my first job was writing IP. This is internet protocol IP. Fragmentation and reassembly and PDP-11 assembler. Nuts and bolts, lowest level, because we were going to port the internet protocol into the Merit network, which was the statewide network connecting the various universities, Michigan State and University of Michigan among them. And I knew people there, so it was an easy fit. And, the next thing I knew, I was tinkering with this IP stuff and kind of wondering what was happening. One of my colleagues at Michigan, a guy named Hans Werner Braun, ended up being the principal investigator for the NSFNet project. So we went out and bid on when the National Science Foundation wanted to replace their first network, which was they in the early 80s, they put up a 6-node network of PDP-11 23s to connect their supercomputer centers. That network was saturated the day they turned it on. In fact, it was so saturated, the guy who wrote the routing software was stealing unused bits in the IP headers and using it as a covert channel to squeeze just a few more bits through there, because it was crazy. We won this NSFNet project in coordination with IBM and MCI as corporate partners. Al Gore wrote the check. He wrote my paycheck. So he did not invent the internet, but he paid for it. Notably, his father created the legislation that created the internet, the interstate highway system in the 50s. And so Al Gore Jr. decided he would repeat his father's, and it wasn't a lot of money, but it paid off, obviously. We put this thing up, and it just, I'll include a graphic of the traffic across the transition to NSFNet 2. It sort of goes like, we turned it off for a month. The internet got turned off for a month, and then it went straight up. And it's been going up ever since.
It appears to me that you think that these protocols are fun. Why?
They show organic behavior. The thing I found fascinating about these protocols, particularly routing protocols, is they're deterministic, but they exhibit surprising behavior. And some of the most fun things is watching things melt down and then go, how did that happen? And then you pick at it for a while and you go, oh. And you start to develop intuition about how the interactions work. And this has sort of become my specialty is I spent a lot of time trying to keep the internet from melting down. It didn't always succeed. But trying to wrangle this chaos. I mean, routing protocols are barely controlled viruses. And if you don't implement them exactly right, they become real viruses. It's an ugly, ugly thing to see.
So from how things work to how protocols work.
Right. I mean, it's sort of the same thing writ large. And I came to realize, we've been talking a lot about control planes and what a control plane means. And a core router especially is the entire internet backbone. Core is a control plane. And the router internally has its own control plane. And its job is it's being forced by the internet to cram things into its control plane. And so its job is to ride this wave of stuff pouring in that it cannot control.
And it can't say no.
And you can't say no. And so this has been a theme of mine through my whole career, which is starting with a completely saturated system and then just trying to keep it alive.
These all seem like very important lessons learned. What are the others that you learn over the course of your career?
Let's see. Well, at Michigan State, the first thing I learned was about customers. The customers there were close enough so you could smell them. I came into the building once, I was probably 20 years old, and I was doing crash analysis. Kind of the first job you do is you spend a year doing build, and then you spend a year consuming these 8-inch stacks of paper that show up in your desk in the morning. And I walked into the building one day, and you could smell the fact that there had been 200 computer science students sleeping in the hallway all night because the computer wasn't up. And the machine room was awfully quiet. And I walk in, and all the operations people are looking at me expectantly. And I sit down at the console, and this is one of those old school machine rooms with raised floors and guys with lab coats and this sort of plexiglass room so you could look. And I'm sitting at the console, and there's faces pressed up against the glass, waiting for me to single step through the boot process of this machine. And I'm going, well, this is pressure. There's the customer. He doesn't look very happy. Now, it was nice getting a little distance from the customer. But I learned two really important things. One is there are customers, and you can either help them or burn them. And the other is bugs are bad. And we had a shop where there was an expectation of no bugs. And that sounds insane, but it was actually quite successful. And what I came away from that process is an understanding of what software quality looked like and how you get it. We were doing 3 levels of formal code review, and Richard Moore, who was the guy who ran the shop, code reviewed every line of code. That obviously doesn't scale. Rami is not going to be reading 100 million lines of code. But there's a level of self-discipline involved in that process, where the expectation is it's completed work. There's this concept of completed work in a lot of fields, and we seem to be losing that sense. I see a lot of writing that's just, okay, this is not completed work. Please go back. So I learned that. And merit, I learned about standards and staying one lesson ahead of everybody else. I had this moment where I walked in my first standards meeting. This was an OSI networking standards. And my colleague who'd been going for a while, this big stack of Xeroxed paper, and what do I do with this? And I start flipping through, and there was, here's something I recognize. It's about something about X25. And I look through this submission, I go, but this isn't right. This doesn't work. How can this be? And my colleague says, well, write a contribution. So I sat down and I wrote a few paragraphs. It showed up in an international standard a year later. And I said, it was just me in a room, right? That the opportunity is there, right? These things that seem shiny and unreachable, it's just other folks. I came to the Valley thinking that all these shiny buildings were full of people who really knew what they were doing. And it's like, oh, these people don't understand circular number spaces. The timestamp is wrapping, and and all the protocols stop. Really? This is this is kind of amazing. So there I learned that I can take large bodies of code, chop them to pieces, and put them back together in order to fix core architectural issues in shipping software, which is a dark art. Greenfield is much more fun. Brownfield is reality. And my specialty became cutting apart, as one of my colleagues put it, changing out the engines on a 747 at 35,000 feet. Moving on to Juniper, I discovered what you could build if you had a team of like-minded, self-starting. I think Juniper's first product, according to Pradeep, who was one of the founders, we built M40 with 41 engineers, which is, that's everything from board layout, ASIC verification, probably 20 million lines of software, something. And I discovered that I could get away with doing what I wanted as long as
You're useful.
as long as I'm useful and I get it right. You can go really far being opinionated as long as you're right most of the time.
Yeah.
It doesn't go far otherwise. And I learned to whisper to executives, because executives really want the truth, even when they don't like it. And I discovered that many people don't like to tell them the truth. So that became one of my side jobs.
Truth teller.
It's the product. If the product doesn't work, I don't care how much you want it to work.
So there were many startups at the time when you started with Juniper. Why do you think Juniper succeeded and others didn't?
A number of reasons. Well, part of it is it was made up of a lot of experienced people in the field. Juniper was put together out of a chunk of people from Cisco who generally did the routing stuff, a chunk of people from Sun. We sort of bought the UltraSpark team and they became the ASIC people, and a bunch of kernel folks from SGI. But part of it was mature people. It wasn't a bunch of 20-year-olds drinking Jolt Cola and sleeping under the table. We had good fundraising. So this was at a time when everybody understood that there was this internet thing happening, and everybody wanted to take it to the next level. And the telcos were clueless, but they all wanted a part of it. So at the same time as we were furiously writing code, the CFO and CTO were going around collecting $5 million at a time from people like Lucent and Nortel, all of whom were expecting everything and received nothing. It helps to have leverage. But you could also tell which ones weren't going to make it, right? There were a dozen startups, and they all had white papers about their fabulous hardware architecture. And then you go looking all the ones that didn't mention software once, these guys are dead.
Yeah.
All the ones that said they're going to run GateD, which was this freeware routing protocol package that said, okay, well, those are dead. And then there's the company where you do the math on the number of ASIC verification engineers. And it's the guys who kind of know how to read that. We're looking at some of these companies going, they'll never make it because they'll tape out and it'll come back DOA and they'll be dead. And a lot of luck. The other thing was, this was my first startup. And it's amazing how motivated you are when you put your life savings down and they spend it before lunch. Yep. It's like, oh, I'm not going to let someone not let this happen. So I'm generally a nice guy and I don't harass people, but there were a couple of people that needed to go. So I was rather uncompromising in my telling management what they needed to do. But the world was ready for it. Part of it is Pradeep was at Xerox PARC, and he was working on parallel computational stuff and memory architectures. And he was thinking a lot about memory architectures, and he said, what kind of problems are there around here that looks like they could use this? And he looked at the nascent networking business, which was all in software. He said, I know how to do this. And he saw high-speed packet forwarding as a memory management problem, which was a piece of just genius insight. And then everybody executed. And yeah, we were a year late, but so was everybody else. It's running 1 million packets a second. Oh, wait, that's 5% of capacity. I mean, even back then. So a lot of uncompromising engineering, a lot of the right people, a lot of luck.
Luck always helps.
Luck, yes. Skill is great, but I'll take luck.
Yeah. So now you are at HPE. You've seen a little bit. How is it different from Juniper? I'm not talking about Juniper as a startup, but Juniper as a mature company that it became in the meantime.
Well, I did notice something right away, which was how driving business is a top line thing. On the fellow manifesto, it's the first line. And you see this called out. And I was sort of amused at first because, at Juniper, it's like, well, of course, because we wouldn't exist and we wouldn't be here if we weren't driving business all the time. We have at the end of the day, we have one product. We have a whole range and they're different sizes, but at the end of the day, we do one thing. And you have to do it well, and and luckily it's not commodity yet, although I'm sure that will happen soon, one of these days. But obviously it's still profitable enough so you guys are willing to pay top dollar for us, which we greatly appreciate. What else is different? There's a bit more formality than I'm used to. I'm obviously an informal guy. I think people take their time more seriously at HPE. I enjoy the fact that you book in half-hour increments when we have calls, and you have to be ready and you have to pay attention. So this is stylistically a bit different. But it's also a big company that remembers what it was like to be a bigger company, which is a fascinating thing to sort of see the echoes of. I'm looking at the collection of fellows, and they're all researchers and PhDs, and Juniper was not a PhD place. It was a nuts and bolts, make it work. And obviously the PhDs were, there was some serious stuff going on in the ASIC side. We had people camped out at IBM, who was the fab at the time, helping them refine their layout software because we couldn't deliver until they could get to the next generation of size reduction. Because we in order to get it all on one chip and all that sort of stuff that the ASIC people work on. And we had good verification people. Actually, I believe Rami was hired in as a ASIC verification engineer originally. So he's done pretty well by it. But yeah, it taped. But the silicon worked the first time, and that's that's the make or break for a startup. But since then, it's a one product company, and so it's very interesting. So there's not a lot of breadth of people, right? And the idea of having a cooling researcher. I mean, I'm sure there are some cooling people in Juniper worrying about airflows and stuff, but
not as many.
Not as many, and not at that level of pure applied research is a bit beyond the event horizon that we were looking at.
I can almost guess the answer to the following question, but I'll let you answer anyways. What are you most proud of in your career, obviously? Well,
I mean, there's this thing called the internet, which turned out pretty well, but I'm actually proud of the fact that no one ever looks at my code because it works, which is this terrible irony, right? Software engineers are trained on terrible code. Probably AI will be similarly trained. And that the great irony is that well-written code nobody ever sees. I wrote the OSPF routing protocol implementation as my first task at Juniper in 1997. That code is still running. I mean, embedded code lasts forever, for better or worse. And I'm proud of delivering industrial quality products that work. So the next natural question is, why do you still code? I can't not. My brain came along at the right time. I mentioned the beginnings of the accessibility of programming, to 14-year-old kids. That I arrived right at the beginning of that. Now I'm looking 50 years on at, AI is going to supposedly replace me. I don't know what that looks like. Am I the most skilled buggy whip manufacturer? I don't know. But I kind of get this feeling that I dropped right into this perfect timeline. And coding is just, it's like breathing.
But there's one other thing that you like as much as breathing, or need as breathing, and that is
music.
So tell us more about it.
The piano was the biggest toy in the house when I was a kid. Took piano lessons. My older sister, who introduced me to computers, she also introduced me to the Beatles and the Stones and the Doors. It was the 60s. I didn't know what to do with it. My parents were classical music fascists, and we all played string instruments and so forth. And I got interested in this bass guitar thing. Got to college, started playing out more, but I was working and then gigging 3 or 4 nights a week, which is a little easier in the university days. Remember, this is the place that said work weird hours with weird people. And so the fact that, I was staying up really late and couldn't get up in the mornings was not a problem functionally that way. We got we recorded, we were professional. My wife went to Michigan. I went there, started working on the internet. About 5 years in, started playing again. Joined the best known local band. It was already, it's a turnkey operation. Mm-hmm. I said, well, I'll do it again if I can get a turnkey operation. We ended up touring the Soviet Union in 1991, just before, in fact, the coup against Gorbachev happened about 2 weeks after I got back.
Unrelated to your visit.
Unrelated visit. Although,
you never know.
I never know. At the time, routers were classified as munitions, and so they were export controlled. And I was advised before I left, you might not want to mention your day job.
Yeah.
Amerykański muzykant. Yeah, that's me. I built a recording studio in my barn in New Mexico. I'm half time between California and New Mexico. I still get together and record bands, and I don't know, I feel it's funny with everything I've achieved in this business, when I feel most legit is in a room full of musicians.
And so how is coding different or the same as music?
They both end up being sequential. Mm-hmm. It's about process and path. It's about collaborating with a bunch of people who you wouldn't otherwise have anything to do with in normal life.
Which is the parallel part, in addition to that sequential.
Yes. It's taking risks, sometimes succeeding, sometimes failing. There's a lot to be said for learning to be foolish in public. Once you've tripped and fallen into a drum kit a couple of times in front of an audience, everything after that is pretty easy. So public speaking, not so hard. It tickles the same part of the back of my brain that it's just an urge. It has to come out. I have an engineer's view of music. I mean, there's a lot of engineering in music. A sound guy over here knows about that. There's also, I'm a bass player, so the bass is an instrument that sort of tacks up the middle between the rhythm section and what's happening harmonically. And so there's a certain amount of geometry involved in finding your path.
So is it fair to say that bass is a control plane of music?
I think so. Yeah, the rhythm section is definitely the control plane, and drummers and bass players have a natural affection. Once again, the people that you would never have anything to do with otherwise. All that pounding does some things with their brains.
Let's go quickly back from music to standards.
Yes.
Not music standards, but technology standards. Tell us a little bit more. You mentioned it in the past. How important are they? Are they still important, or they're going away? How do they manifest?
Standards will never go away because it's the only way we can. I mean, especially in the networking business, you don't have a network if you don't have standards. And I know you're working on data center standards. They're a necessary evil. They done well, they're marvelous, and you can get a lot done. The meetings tend to more and more get filled with professional meeting goers, which is a little less helpful. But about a real story out of the standards world, we were putting up the NSFnet in 1988, 89. We had 8 months from grant award to turning on the internet, which was a pretty good trick. And early on, it became apparent, we actually need interdomain routing. This network is going to touch down, going to touch the ARPANET at multiple points. There's no interdomain routing protocol. What's happening in the IETF? Well, there's this IDR working group that's been going for years, and they have all kinds of important policy-based, lots of algebra, and there was no code and there was no standard. And it's like, we have to deliver this thing. So Kirk Lougheed from Cisco and Yakov Rector from IBM Yorktown, who was part of Merit, NSFNet, sat down and sketched out a protocol. And there's some question is whether it took 2 napkins or 3 napkins. Literally over dinner, sketched this out, went back and coded it. Cisco implemented it, NSFNet implemented it, and then GateD, Jeff Honig at Cornell implemented it. And then we brought it as a fait accompli to the IETF. Said, by the way, this is the way the internet is running. Would you like this protocol? We'd love you to standardize it. Oh, they were very unhappy. But we're still running it 40 years later, better or worse. It's there's not a lot of protocol there.
So these are amazing examples. But from your perspective, what did you find most gratifying in your career?
That I was trusted to do these crazy things. My day job is something that no software manager should ever allow.
Yep.
But they still let me do it, and I can still do it. And as a result, I can impose my will on the system. Right? And it's tremendously gratifying to have that level of trust. I mean, if I screw up, it makes the front page of the New York Times.
Yep.
And so, thank you. But it's also exciting, that riding that edge. That the experience of having the faces pressed up against the plexiglass cured me of any sort of nervousness I had about operating in that space. I'm a very aggressive engineer. I know just how far to push it before it becomes
prepared you for
untenable.
all these musical performances.
Yeah. There are some good ones and some bad ones. We were only rated by the cops. No, Marines. We had the Marines pull out all of our plugs once. That's a long story.
So other than Marines pulling out the plugs, what would you do differently if you would start all over?
Oh, do differently. It's hard to argue with how my career turned out, frankly. I might have been a bit more focused early on. I spent my first 9 years kind of sitting back going, yeah, this is nice. I could stay here forever. And my wife said, let's move to Ann Arbor. I said, And then we started running into the outside world. Now that was, the big change was by the time I moved to California, I knew more people in California than I did in Michigan. But I can't complain. I have the best job in the world. I've been doing it for half a century, and it's still exciting. I get up every morning, refer to Chandrakant Patel again. He said, every Monday that I get on the bus and I'm happier than I was when I came home on Friday, I keep going.
Yeah, exactly.
And that's where I am right now. I'm still trying to figure out what I'm going to do here in the next phase. But
so needless to say, most of your work contributes to the whole of the world because, there's so much data running over your router switches. But in terms of the broader good for the humankind, how does Juniper contribute to that and HP today?
That is an excellent question. Everything is about AI now, and I have, I'm of a certain age, and I'm made extremely nervous by what's happening. I don't know how it all, and my part in it. Clearly, I have a part in it. The creation of wealth, on a personal level, my wife mostly did the work, but we created a nonprofit early on in 2000 to do work around HIV and AIDS in children in Africa, and it turned into a public charity, and it's still going, and we're not involved anymore, but seeing the knockoffs, those, I guess the part of it that other than we built these pipes and there's good things and bad things that flow through them. And I think it's mostly been a good thing, but I think in terms of helping the world, what people have done as individuals, is as important.
We always ask our guests if they can recommend any book. Have you read anything recently or long time ago?
Well, I read cheap British detective mysteries to my wife at night when we go to bed.
That's nice.
The last chilling book I read was called Command and Control, which is a nonfiction about the nuclear deterrent in the U.S. and the history of that program, framed around the guy who dropped a socket from a socket wrench down a Titan II missile silo in Arkansas in 1980, popped a hole in the side of a Titan missile and blew a 100 megaton warhead out through the roof of the place. And so looking at that and looking at my place in technology, you're just going,
A lot of similarity.
yeah, well, when I was in school, the recruiters were coming around offering jobs to build a better platform for the cruise missile. And that was what that's what industry looked like. So I was sort of happy to stay in the neutral territory. And I said, oh, the internet won't kill anybody. And then, not so much anymore.
What do you do in your spare time when you don't code and play music?
Don't code and play music. Sleep. Eat and sleep. I was a pilot until recently. I had commercial multi-engine rating and used it mostly to get back and forth between California and New Mexico. Although I decided to give it up recently just because I don't think I'm doing it enough to stay safe and getting to the point of taking Grandpa's keys away. I didn't want to go that far. So I'm kind of in transition as to, what it is that I want to do on the side. As I'm 68 now. I'm still functional. I still love the work, but I'll have to learn to do some other things.
And my last question is, as you were growing up throughout your career, how are the times different then and now? And especially where you live now, beautiful house in Santa Cruz.
Well, I was raised in a segregated suburb of Detroit. And Detroit had the worst of the urban riots in 1967. My parents were, as it turns out, radicals trying to integrate housing in this white suburb of Detroit where I grew up. So that was a significant difference. Then I moved to California where everybody's from somewhere else. And there kind of isn't a majority. And I got used to that. And going back to Michigan, even though Michigan has moved on and my town is no longer all white. But it's still, I appreciate what this place has meant. That a guy like me can be a VP. I mean, come on, look at me.
Hey, Dave, great stories, amazing career. Thanks for joining us.
Thank you, Jan.